Okay, this is the problem this is a review problem about frame and machine, and this one is machine because it's made to move. So the parts are made to move using the pin connection. So we have some pin connection. Let me write the pin connection F. Let me make them in red. Pin connection at F, pin connection at E, at D, at C, at H, those 2 points, and at A. Okay, so the information that we have is the weight, and we know that the shovel have a mass of 1.25 megagrams, so the weight is equal to 1.25 times 10 at the third times 9.81 Newton. Or we can write it in kilonewton if we want. Let me write it in kilonewton. 1.25 times 9.81, and it will be kilonewton right away. So 1.25 times 9.81. This is 12.26 kilonewton. Okay. So the two questions are find the force in the cylinder EF, so this one, and the force in the cylinder AD. Okay, let's do EF first. Okay, so cylinder EF, 2-pin connection, no weight on the cylinder EF. So EF, it's a two forces member. It means that the force is aligned with the member EF. So we can take this. We need to take a body, so we can take anything as a body. We can take just the shovel and one part, the shovel and two parts. Okay, anything. We will take as a body this. So the shovel plus the arm, the front arm. So now, if you look at, there is a point H where there's two unknown force, Hx and Hy. At EF, we have just one unknown force, and because we know the direction. And at G, we have the weight. If we do the moment about H, so we will do the moment about H. This weight turn in this direction, in the negative directions, so the force EF must rotate in the positive direction to balance the weight. So we know that the force EF will be in this direction. Okay. So when we do the moment, the equation of moment about H, so we will do sum of the moment about the point H, it's equal to 0. Okay. We need the minimum distance between the point H and the force G, and remember, we can slide a force on its line of action. So G, okay, we can slide the force, the weight on this force, so the minimum force, minimum distance that we need between H and G is this distance, that's the 0.5. Okay, so for the weight, we have minus the weight times the distance of 0.5. And now for the force EF, minus because it's going in the negative direction. The force EF, so we have a right angle there. That's not written on your graph, but we have a right angle there. So what we need, that the minimal distance between EF and the point H. So that's this one. Okay, so we need this distance. Let's call this distance D. Okay, so it will be equal plus the force EF times the distance D, and it's equal to 0. So to find the distance D, we will go in a triangle EF, right angle there, and this long distance, this one. This long distance is 1.5. This angle is 30 degrees, and the distance D is this one. So we have the sine of 30 degrees, that is equal to the distance D divided by 1.5. So D is equal to 1.5 sine 30 degrees, and D is equal to 0.75 meter. That's 1/2. So let's replace d by 0.75 and the weight by 12.26. So we have minus 12.26 times 0.5 plus EF times 0.75 equals 0. So we find that EF is equal to 12.26 times 0.5 divided by 0.75. And it's in kilonewton because the 12.26 is in kilonewton. So 12.26 times 0.5 and divided by 0.75. It's equal to 8.175 kilonewton. Okay, so that's the first answer. Now the second question. So let me clean that. Oops, let's be clean a little bit. We know now EF, but we don't need it anymore. And let's clean everything. Let's clean everything. Okay, the only thing that we keep is the G. And what we need to find now is the force AD. So this one. So we need to find a body that does not include AD. So either the point A that cut at the point A or the point D. And as one force that we know, so it could be the force ED, EF, or the force G, force W at G. And maybe just one pin connection when we can take the moment. What about this body there? So everything is internal forces, like the pin connection at E, at F, at H, those two forces, that's internal forces, so we don't include them. The only force that we include is the weight at G. And now we have, let me find something that one can see. We have the point D and we have the point C with external forces. At C, we have two unknown, Cx and Cy. At D, we just have one because AD, it's a two forces member. So we know the direction. So we will do the moment, we cannot see it anymore, but that's the point C. So we will do the sum of the moment about the point C, it's equal to 0. Okay, so what we need the distance, because we see we need the distance between C and G. So this distance, okay, this distance, let's call this distance A. So let's find A. So to find A, we have everything there. So we have 0.25 plus 0.25 plus 1.5, and there's an angle of 10 degrees there. So cosine 10 degrees. So this is this distance and plus 0.5. This is the distance A. So A is equal to 0.25 plus 0.25 plus 1.5 times cosine 10 and plus the 0.5. So this is equal to 2.4696. Okay, keep everything in your calculator. Meter. Okay, so that's the distance between C and G, the perpendicular distance, the minimal distance with the vector weight. Okay, and now for the force AD. So first, W is going in the negative direction, so the force AD must go in the positive directions to balance the moment of the weight. Okay. Now we have an angle there of 60 degrees and an angle there of 10 degrees. So, and this distance between those 2 points is 0.25. Use another color. Okay. So we have, let's do this little triangle. We have 0.25 and we have 10 degrees. Okay, like this. And we have the force that apply at this point with an angle of 60 degrees. So if we, let me use the way I prefer to use that. So that's at this point that we apply. Yes, so I know that we need to tilt to have the angle of 50 degrees. So what will be convenient is just to find the projection on this distance, but let's do other way. So this is the vertical complement of AD, and this is the horizontal complement, and the horizontal complement is going a little bit above the point C. Okay, so this one is the sine 60, and this one is the cosine 60. Okay, so for AD, this first AD sine 60 need to be multiplied by the horizontal distance, so it's 0.5 cosine 10. Okay, and this vertical complement rotate in these positive directions. Now the horizontal complement, AD cosine 60, at this one, it's above the point C, and it's rotated in the negative direction, and it's time, so minus, and it's time 0.25 sine 10 degrees. And my weight is rotating in the negative direction, so minus the W times the distance A that we found, 2.4696. And it's equal to 0. Okay, so we have AD that is equal to the weight 1.25 times the distance 2.4696 and divided by sine 0.25. Okay, time sine 60 cosine 10 minus cosine 60 sine 10. And this is equal to 1.25 times your distance and divided by 0.25 and time, open your parentheses, sine 60, and I will show you cosine 10 minus cosine 60 sine 10. And this is equal to what I missed there. And time, the 1.25, sorry, time 9.81. I forget this one, time 9.81. And this is equal to 158.1 kilonewton. Let me rewrite it there. Kilonewton. Here we go. And there's one thing I want to tell you about this. Instead of using this formula, we can write it sine A cosine B minus cosine A and sine B. And if you go on your formulation of all your math formula, this is equal to sine A minus B. So it will be equal to sine 60 minus 10 is equal to sine 50 degrees. Okay, so instead of using all those complements, what you could have done is you could have multiplied AD by the sine of 50. So you will have found right away the perpendicular force, this one, to the distance of 0.25. So 0.25 time, this one is AD sine 50, and we will have found the AD. Okay. but you need to include the 10 degrees and the 60 degrees to find the AD 50 degrees. Okay, so just to come back on the steps, what we did, okay, so first, free body diagram, we use this body, and we find EF using the moment about H, and the same free body diagram, we use this almost the entire arms, and we did the moment about C to find the force in AD, because there are two force members, so we know their directions. So that's it. I see you in another video. Bye bye.